Okay, let's try to solve this equation. We'll have a rational expression on the left-hand side, which means x, the variable x appears in the denominator. And on the right-hand side, we'll have polynomial degree 4. So solve this kind of equations, we want to construct common factors. So we want to put the expression in a factored form. So in this case, so let's see, we want to move them together. So we do x raised by 4 minus 11x minus 6 over 6x minus 11. Okay, my equal to 0 too far. So how can we construct or manufacture common factors here? We want to put in a factored form. Let's try to simplify this term. Let's see if we can rewrite this term. So we have 11x minus 6 divided by 6x minus 11. So we split 11x into 6x plus 5x. So let's do 6x plus 5x. Then let's try to manufacture negative 6 into minus 11. I want to, because 6x minus 11, we can simplify with the denominator. But I had a negative 6, now I have negative 11, so I have a plus 5. So I can rewrite this as 6x minus 11 plus 5x plus 5 divided by 6x minus 11. Now, when I divide like this, I get a 1. Right? Then I get a 1 plus 5x plus 5, I can factor out 5. So I can write it as this. All right, so let's put back in here. So I can write it as x raised by 4 minus 1, because I have this minus here. Right, minus sign, minus 1, then minus 5 times x plus 1 over 6x minus 11. Okay, x raised by 4 minus 1, we can think as x squared minus 1. Difference of two squares. Right? We can factor as x squared plus 1 times x squared minus 1. Then x squared minus 1, we can factor as difference of two squares again. Now we see common factors pop up, x plus 1. So x raised by 4 minus 1, we can write as x squared plus 1 times x plus 1 times x minus 1. And this term, we have 5 over 6 minus 11 times x plus 1. So we have manufactured common factor x plus 1. Now we can put the expression into factored form. So factor out the first one, we have x squared plus 1 times x minus 1. Then minus 5 times 6x minus 11, that equals 0. Okay, so then we can use the zero property, right? So product of certain things to be 0, that means each factor can be 0. That means x plus 1 can be 0. So get a first solution, x equals to negative 1. Right? We can plug in to try. X equals to negative 1, we'll get negative 11 minus 6, that's negative 17. Negative 1 times 6, negative 6 minus 11, negative 17. Negative 17 divides itself, that's positive 1. While on the right-hand side, negative 1 raised by 4, raised by even number is positive 1. So negative 1 is one solution. But now we still have another factor. We still have this factor. So this factor, we don't have common factors yet. So what do we do? But this factor equals 0. So we have, let's write them x squared plus 1 times x minus 1 minus 5 times 6x minus 11, that equals 0. Now let's just multiply 6x minus 11 on both sides. So we get x squared plus 1 times x minus 1 times 6x minus 11, then minus 5 equals to 0. So what do we do with this? We have to expand, right? Because there's no way we can make a common factor. So we have to expand the product of these three. So we get x squared plus 1. Let's multiply this binomial times binomial. So x times 6x, we get 6x squared. Then x times negative 11, we get negative 11x, negative 1 times 6x, negative 6x, we'll get a negative 17x for middle term. Then negative 1 times negative 11, that's positive 11. Minus 5 equals 0. Now we have to multiply this binomial with a trinomial. So let's multiply x squared with everyone. So 6x raised by 4 minus 17x cubed, then plus 11x squared. Then multiply 1 with everyone in the second term. So 1 times 6x squared, that's positive 6x squared. Then minus 17x, then plus 11. So then minus 5 equals to 0. So those two are like terms. So we get 6x raised by 4 minus 17x cubed plus 17x squared minus 17x. The 11 minus 5, we get plus 6 equals to 0. Okay. Okay, how does this help us? We could try to see if it's factorable. 6x raised by 4. Maybe, let's see. Let's work with these two. 6x raised by 4 plus 6. Then, because this 3 has 17. We can factor out this 17. Okay, let's try this way. Oops, I don't have enough space. I need to erase something. Let's erase all those calculations. Okay, let's work in this spot. So let's write as 6x raised by 4 plus 6. At least these two has a common factor of 6, right? Maybe we want to write as 6 times x raised by 4 plus 1. Then minus 17, let's factor out x cubed minus x squared, then plus x. Yeah, maybe we should factor out 17x. Well, let's see. So now this equals to 0, right? So it's more organized now. Minus 17x cubed. Okay, that's positive. Then positive x 17x squared becomes negative. Then negative 17x becomes positive, right? Let's actually factor out 17x. So minus 17x. Now the inside becomes square and 1. Right, so x squared minus x plus 1. All right, now what to do? We see if we know x raised by 4 plus 1, x squared minus 1 plus 1, we want to make perfect squares. So we know from here we see x cannot be 0, right? If x is 0, the left-hand side becomes 6, but the right-hand side is 0, so that means x won't be 0. So if x won't be 0, let's divide it by x squared. Let's divide by every term by x squared. So let's see. Then something happens very nicely. So we have 6 multiplied by x raised by 4 divided by x squared. That would be x squared. Then 1 divided by x squared would be 1 over x squared. And we want to make this perfect square. So maybe we'll do later. Okay. Then minus 17. Now, x divided by x squared, it just becomes x, right? Then x squared divided by x, that's just x. Then x divided by x, that becomes 1. Then we have plus 1 over x. Okay, beautiful. All right, now let's make perfect square. So to make a perfect square for this, I need to plus 2 minus 2, right? Plus 2 will be my middle term for perfect square of x plus 1 over x squared. Right, first one square, middle term is 2 times x times 1 over x, which is 2, so I plus 2. But then I need a minus 2 as well, because I don't have 2 there. So I can only add a 0. This 0 is 2 minus 2. Okay, that's my first one. So the second one, minus 17. You see, we have x plus 1 over x. X plus 1 over x minus 1. Right, we erase this. Now, so we are in a, actually, let's write down this one out. Because minus 17 times minus 1 give us plus 17. Okay, let's treat this one as another variable, right? Let's think x plus 1 over x maybe as 8. You see we have 6 of a squared. Yeah. 6a squared. Then 6 times negative 2, that's negative 12. Negative 12 plus is 17, so we're changing this 17 to be plus 5. So we have 6a squared minus 17a. So I read too far. So plus 5 equals 0. Let me erase this. Now, can we factor this? If we can factor this, yes. You see, 3 can be split into 2 and 3. Then 3 times 5, 15. 15 plus 2, 17. Okay, so we can factor out this as 2a. Let's use a for x plus 1 over x for now. 2a minus 5, because the middle term is negative, so my 2 factors will be negative. And 3a minus 1. Right, in this case, we still have 6a squared. We have negative 2a, negative 15a, add up to be negative 17a. The negative 5 times negative 1, positive 5. Bingo. All right, so this gives us 2a minus 5 is 0. So 2a minus 5 can be 0 by 0 property. The solve for a equals 5 over 2. And this one, 3a minus 1 can be 0. So that means a can be 1 over 3. Okay, remember a is x plus 1 over x. So let's try to solve that. So first one, x plus 1 over x equals to 5 over 2. Let's choose the color, right? So then solve one this, so let's multiply by 2x on both sides. So we get a 2x squared minus 5x, right? We want to multiply every term by 2x because the common denominator is 2x. We multiply every term by 2x. So x times 2x times 2x squared. Then 1 over x times 2x, that's plus 2. 5 over 2 times 2x, that's 5x. Let's move 5x to the left-hand side. So we have 2x squared minus 5x plus 2 equals 0. Okay, this can be factored. Right, we can factor as 2x minus 1 and x minus 2. Right, the middle term will get negative x, and negative 4x adds up to be negative 5x. So that gives us x equals to, the first one, 2x minus 1 can be 0, so x equals a half. This one gives us x equals 2. So we get two solutions from this one. Remember x equals negative 1, so we have 2 more solutions. Now let's see when x plus 1 over x equals 1/3. So x plus 1 over x equals to 1/3. Let's do the same thing. Let's multiply by the common denominator of 3x on both sides. So we get 3x squared. Now 1 over 3 times 3x, so that's just x minus x. Move to the left-hand side becomes negative. So plus 3, right? 1 over x times 3x, that's 3 equals to 0. Oh, okay, obviously, this is square root. Under the square root, the discriminant is negative, right? Because b squared, which is negative 1 squared, is 1, minus 4ac, 4 times 3 times 3. But this is less than 0. That means this one, we will have complex solutions. If we want to solve complex solutions, let's do that. So I have 3 rational solutions, then 2 complex solutions. So remember x equals to negative b plus minus the square root of b squared minus 4ac, quadratic formula, divided by 2a, right? B is a number before x, right? Negative 1 becomes just 1, 1 plus minus square root of negative 1 squared is 1, minus 4 times 3 times 3, divided by 2 times 3. So that gives us 1 over 6, 2 times 3, 6, plus minus 1 minus 4 times 9, 36, so negative. So I square root of 35 divided by 6. So 2 complex solutions. So overall, we have 5 solutions, 3 rational solutions and 2 complex solutions.